A ball, the next question, a ball is sent up vertically by hitting it up with a velocity of 25 meters per second. That's the velocity with which it was hit up. U 25 meters per second. A ball was hit up with that velocity. When the ball goes up, it will experience acceleration due to gravity. Against it, that's a deceleration. And at the highest point where the ball will be, it must stop before it starts coming down. So when it stops, its final velocity will be 0 at the highest point before it starts coming back, because it experienced, and we're using acceleration due to gravity G equal to 10 meters per second squared. So the question now said, what is the highest height traveled by the ball that was hit up? What's the highest height traveled? To get the highest height traveled, I can use the last equation, which is this. The final, at the highest height, the velocity is 0. That is v squared. The final velocity is equal to the initial velocity, which is 25 squared. It's going against gravity, so it will be decelerating. Like gravity will push it down, so it will be negative acceleration. Minus 2 times 10 times s. So from here, s is equal to 25 squared over 20. S is equal to 25 squared over 20. From that equation, which is the highest height, which that height is equal to 31.25 meters. 31.25 meters. So the highest height traveled by the ball is 31.25 meters. So the second question says, first question says the highest height. Second question says the time. The time for the ball to reach its highest point. We can use first equation. The time for the ball to reach its highest point. Because at the highest point, the velocity is 0. So v is 0. U was 25. Then minus, because it's against gravity, 10 times t minus 10 times t. So to get the time, we travel the highest height, which is equal to t is equal to 25 over 10. It is equal to 2.5 seconds. That's what he used to get to the highest height. Then the next question says, what time did he use to come back to the thrower? It is double the time. It is 2 times this, which is 5 seconds. But if one doesn't want to do like that, one wants to still get it. When it's coming back, it is double that. But if one still want to calculate it, one can say that when it is coming back, this final velocity when it was going up now becomes initial velocity. It becomes initial velocity, so that is 0 as it's coming back. And that initial velocity, we can now use the second equation, since the initial velocity now is now 0. So this part of the equation goes away. We now have that s is equal to half a t squared, because the u, which is now the initial, is 0 as it's coming down. So if that's the case, then we have the distance traveled up is 31.25 is equal to half times 10. That is this essential prevalent times t squared. Then t squared is equal to 6.25. T squared is equal to 6.25. T squared from here is equal to 6.25. Then t is equal to square root of 6.25, which if you do it, you see that it gives you 2.5 seconds. So if you add it to the other 2 points, you see that it's 5 seconds. So the total time used to come back to the thrower will be 5 seconds. You used 5 seconds to go up, you used 5 seconds to come back. twice this,